You've clicked on to Electric Power and Energy Part 2, where we're going to go through some traditional Regents physics problems using the power and energy formulas that we learned in the last video. Let's try this problem. Calculate the resistance and current of a 7.5 watt night light bulb plugged into a 120 volt outlet. Well, first of all, let's look at what we've been given. We've been given 7.5 watts, which is a power, and we've been given that is a 120 volt outlet. That's a voltage or electric potential difference. And we want to know what the resistance would be, and we want to know what the current would be. So we look at our reference tables, and when we ask the question, how do I find resistance? I see that resistance is equal to voltage over current. I do have the voltage, it's 120 volts, but I don't have the current. In fact, that's what one of the things I'm being asked for. So let's see if I can find the current. Well, I've been given the power and I've been given the voltage, so another relationship I have is power is voltage times current. So I see that I do have power, 7.5 watts, 120 volts, so I could solve this for current. So let's do that. So current will equal 7.5 watts divided by 120 volts. So that's going to be 0.063 amps. Now to get the resistance of this light bulb, the night light bulb, resistance is equal to electric potential difference divided by current. So that would equal 120 volts. And I just found out it's 0.063 amps. And that equals 1905 ohms. Alright, let's try a tougher problem here. Problem says, which would be thicker or wider? The filament of a 60 watt light bulb or the filament of a 100 watt light bulb? Explain. Now what makes this problem a little bit tougher is I have to think about it before I know what I want to solve for. So before I start hunting for formulas, let me think about filaments here first. If I remember when I looked at filaments under the microscope, when we were doing the round bulb and the long bulb, there was a relationship between the thickness of the filament and the resistance. So for instance, the round bulb had a thicker filament and therefore it had a lower resistance. The long bulb had a very thin filament and it had a high resistance. So what I would really like to know for these two light bulbs is what's the resistance. Now let me ask what I know, and what I know, what they give me are the wattage ratings of the light bulb. So they tell me the power. And the other thing that is implied but not told here is that we're using them in our homes. So whenever I think that the device that they're telling me about is used in a normal home, I can assume that the voltage is the voltage of our wall sockets, which is 120 volts. So there's a couple ways to go here. One way is to directly solve for the resistance using formula in the reference table, or the other way is to think, if what I really want to know is what the resistance is, I know that the lower resistance, which would be the thicker filament, the lower resistance would have the higher current. So if I use the formula power equals V times I, if I can solve for the currents of each of the two light bulbs, whichever current is higher would have a lower resistance and therefore a thicker filament. So let's do that. So let's say the power, we'll do each light bulb separately, 60 watts, voltage is 120 volts, and I want to know what the current is. And the other light bulb is 100 watts. So we'll do each of them and see which one's current is higher. So for the 60 watt light bulb, using this formula, current is power divided by voltage. So we'll do the 60 watts divided by 120 volts. So the current is going to be half an amp for that light bulb. Now let's do the other light bulb. The current is going to be 100 watts divided by 120 volts, and that's going to be 0.83 amps. So this is the current for the 60 watt bulb, and notice if I go up to 100 watts, the current is higher. Higher current goes with lower resistance. Lower resistance goes with a thicker filament. So I know, like in a three-way bulb where you have three different wattages, what I must have is the lower wattage light bulb has a thin filament, the middle wattage setting has a thicker filament, and the high wattage setting has the thickest filament. That the higher the wattage, the higher the current. Okay, the last kind of problem that they'll ask us about are problems where they want to know how much energy is supplied to a circuit by a battery, or how much energy is lost through a light bulb. So I need to think about the relationship between power and energy, and those are related primarily through this formula. Power is work or energy, remember the W means energy also, over time. So if they say, well, how much energy is used up, that's just simply equal to the product of power times time. But I do have to remember that if I want this answer to be in joules, the unit for power is watts, which is joules per second. Now, the way to get the number of joules is I would have to multiply the power times the time in seconds. So whatever time they give me, I have to convert it to seconds so that then I could cancel out the seconds and get joules. Now here's what it looks like on our reference tables. So I have power equals voltage times current, or it's current squared times resistance, or power could also equal voltage squared divided by resistance. Now just like we did up here, work is always equal to power times time. So I could take each of these ways to write power and multiply them times time to get energy. So energy would be equal to voltage times current times time, or energy could be equal to I squared R times time, or energy could equal V squared over R times time. So these are all ways that I could figure out how much energy a circuit is using. So let's try a problem. How much energy does a 120 watt light bulb release in 5 minutes? So I realize 120 watts is a power, and I realize that 5 minutes is a time, and I want energy, which I have to remember on the reference tables is a W. So the main formula is that power is equal to work divided by time. So I rearrange it to get energy is power times time. So I'm going to multiply 120 watts. But remember, 120 watts is 120 joules per second. So I need to write the 5 minutes in seconds. So there's 5 minutes, but there are 60 seconds per minute. So really it's 300 seconds. So if I multiply 120 times 5 times 60, I actually get 36,000 joules of energy. So a 120 watt light bulb pumps 36,000 joules into my living room in 5 minutes. Grand finale question. TV draws a current of 2 amps when connected to a 120 volt household circuit. What is the resistance of the TV, the power rating of the TV, and the amount of energy the TV uses in a half hour? So I am told that the current the TV draws is 2 amps. And I know that in my house, the wall sockets are 120 volts. And the first thing they want to know is the resistance of the TV. So resistance is voltage divided by current, 120 volts over 2 amps. So the resistance of the TV must be 60 ohms. Second question is, what is the power rating of the TV? So power is V times I. So the power is 120 volts. I'm sorry, the potential difference is 120 volts. Current was 2 amps. So that gives me a power rating of 240 watts. And the last part was, how much energy does the TV use in a half hour? So amount of energy is equal to power times time. So that would be 240 watts. And again, I have to get the time in seconds. So a half hour is 30 minutes. And there are 60 seconds in a minute. So I multiply all those numbers together and I get 4.32 times 10 to the 5th joules.